Good to have you back. In this screencast, we take a look at the relationship between roots and factors and the relationship between roots and factors and the coefficients of the quadratic from whence they came. So the root factor connection is a big deal. Why? So let's pretend that we have a quadratic and it factors as x minus p, x minus q. Well, when we go to find roots, those roots come from x minus p, x minus q equals 0. And we know, because of the zero product property, that if a product of numbers multiplies to 0, then one or the other is 0. And that means that either x is p or x is q are roots of the quadratic. In fact, they both are. They both make the equation true. So there's a connection between x equals p is a root and x equals q is a root, and x minus p times x minus q equals 0. There is a connection between roots and factors, and that comes into play here. So suppose you're writing a test question, you want a parabola on your test, you want that parabola to have x-intercepts at 4 and -2 and a y-intercept of 24. What equation should your parabola have? Think about it for a moment. You want x-intercepts at 4 and -2 and a y-intercept of 24. It's gotta look like this. Pause for a moment. Think about what equation the parabola should have. Okay, if the x-intercepts are 4 and -2, then x minus 4 is a factor and x plus 2 is a factor. All my abstract algebra friends will recognize this as the root factor theorem. This is sort of a big deal in algebra. So the only thing that we don't know is what the stretch factor is. That we don't know. We know that the parabola should have this equation. We don't know what the stretch factor is. So how do we figure that out? Well, we know this piece of information. We know that the y-intercept is 24, which means that 24 is the y value when the x value is 0. And conveniently, it is possible to find the a value without too much arithmetic. And so the equation of the parabola should be y equals -3 times x minus 4 times x plus 2. Or, if you like, you can expand that out and get -3x squared plus 6x plus 24. This one covers up where the roots are. This one lays bare where the roots are. So if you want the students to find the roots, you pick this one. You've rigged it up so that you know what the answer is, and they don't know any better. Question 2. Pause for a moment. See if you can decipher. We're looking for the unique quadratic polynomial p of x with integer coefficients, lead coefficient 1, 7 plus root 6 is one of the roots. Well, where did this 7 plus root 6 come from? It came from x equals -b plus or minus square root of b squared minus 4ac all over 2a. So if 7 plus root 6 is a root, then 7 minus root 6 is a root. As long as the coefficients are integers, roots come in what we call conjugate pairs. If 7 plus root 6 is a root, 7 minus root 6 is a root. So the roots are 7 plus root 6 and 7 minus root 6. So how do we use that? Well, we think about what the sum of the roots are and what the product of the roots are. and see if we can make a connection between the coefficients of the quadratic equation and the roots that they generate. So the sum of these roots, well, the sum of these roots is negative b plus the big scary radical over 2a, and then negative b minus the big scary radical over 2a. Well, what's that sum? Well, these go away, and you get negative 2b over 2a. That's negative b over a. The sum of the roots of a quadratic equation is negative b over a. Well, similarly, how about the product? Well, the product of the roots is negative b plus big scary radical over 2a times negative b minus big scary radical over 2a. Well, that's okay. And then the numerator, uh, that's oh gosh, b squared, and then those drop, and then you got minus b squared minus 4ac. Well, how does that simplify? Uh, okay, right? Right? So the product of the roots is c over a. And in this case, we know that the lead coefficient is 1. So we know that a is 1. And so the sum of these roots, which is 14, is negative b. And the product of these roots, which is not terribly hard to find, is c. And we can write the unique quadratic polynomial p of x as x squared, b is negative 14, c is 43. That's a quadratic polynomial with integer coefficients. The lead coefficient is 1. 7 plus root 6 is one of the roots. And we have made the connection between sum and product of the roots and the coefficients, and you know that it's legit, it didn't just fall from the sky. So I hope that that's helpful, and I'll see you in class.